Last time, okay. Equivalent circuit diagram of induction machine. Do you remember equivalent circuit diagram? Equivalent circuit diagram of induction machine. Basically, there is a rotor as well as stator. Just we are doing nothing. Just we are representing the parameters of stator as well as rotor. RS and XS belongs to stator, while RR1 and XR they are for the rotor. This one is for the mutual reactance. The existing reactance in between the stator as well as rotor. Along with this, there is one resistance, that is R M. The resistance which is responsible to create core losses. The resistance which is responsible to create core losses when transformer or the machine is on. If there is a flow of current through a particular core, then there is some core losses. I hope you get this. Core you know, the losses you know, and the resistance offered by that core is the core losses. And now what we are doing right now, the impedance or reactive impedance or reactance, it is also the core reactance, you can say. Or you can say the reactance exists or offered by the mutual inductance in between the two windings. One is stator, another is rotor. Generally, I gave you, or just last time I gave you one homework that we want to transfer this XM and RM from the center to the primary side. We want to eliminate this from the entire circuit gradually, or we want to simplify this circuit so that we can find out all parameters in the simple equations, and we can carry out for the next equations either in terms of the voltage or current. So what we discussed, based on that discussion, the value of RM, value of XM, both are somewhat large. Both are large. So they can be assumed, or they can be neglected that there may be open circuit. There may be open circuit, or the impedance offered by these two parameters might be very large, or there may be no connection in between the first positive terminal as well as the negative terminals. Or in short, there is no such type of connection exists in between the phase to the neutral. This impedance or this reactance as well as the resistance, the value of these two parameters are somewhat large, which can be assumed as they may offer very large impedance. They may offer very large impedance, and if it is very large impedance, that means it will work as an open switch. Is it clear? So many times we are neglecting the value of these parameters while calculations of the rest of the parameters. But for the sake of further understanding, yet we remove the value of R, resistance, yet we have connected the value of XM. આટલે સુધી ક્લિયર છે? સર્કિટ ક્યાંથી ક્યાં આવી પહેલા સીધું હતું, પછી વચ્ચે લઈ ગયા, પછી આપણે this is the current, this is input current, and the current which is passing through the stator is the same current is passing through the rotor current. So we are saying that the rotor current is now referred to the stator. The rotor current is now referred to the stator. I hope that you studied earlier. Stator current is referred to the rotor. Rotor current is referred to the stator. There were basic equations V1 by V2 is equal to I2 by I1 is equal to K is equal to N1 by N2. આ બધા basic equations પરથી આપણે શું કરતા V2 લેવું હોય તો K ને મલ્ટીપ્લાય કરો, પહેલામાં લેવું હોય તો K ને ડિવાઇડ કરો અને એ તમારે ક્યાં લગાવવાનું જે બાજુ રિફર કરતા હોય either from the rotor side or from the stator side એ રીતે તમારે લેવાનું. હવે આગળ વધીએ આપણે. Just we are understanding that there are two parts. One is the stator, another is the rotor. Whatever the parameters on the rotor side, we want to transfer it to the stator side. Why? Because we want to make a circuit very simple or the better for the further calculation, further analysis. One एक side circuit હોય બધા parameters एक side હોય તો આપણે easily we can calculate all the impedance, all the current, and we can say that this is the current passing through the rotor. This is the current access into the stator. એવું બધું કેવું પડે. तो આપણે બધું જુદું કરવું પડે. The simplification of the entire circuit is what we are doing. We are transferring from the rotor to the stator or from the stator to the rotor. Understand clear? It is important for us. Circuit diagram, equivalent circuit diagram is important for us. Now let us go ahead. You should write down some of the equations important for this topic as well as for the examples, and then finally for the future exams, and then for the internal and the external exams. So these equations you should remember, starting from the first, stator copper loss. Stator copper loss 3 times Is square into R. We are saying PCU, so copper loss. Stator copper loss, very easy to understand. There is one stator. This one is your stator. Whatever the supply, there is a flow of current. There may be some resistance, there may be some reactance. We have to calculate the loss of the stator. There is a 3-phase winding. Then it is a. We are discussing about the 3-phase winding, so that's why it is multiplied. It is a very simple basic equation, I square R, stator copper. Then there is another equation, rotor copper. Which is PRU. 3 times again. Instead of IS, it is IR into R. Not RS, but R. You should write down. The losses are important to calculate the overall efficiency of any machine. So that's why we are finding the losses. Third one is core loss. That is PCU, which is approximately equal, not exactly equal, which is approximately equal to 3 times Vm square upon R, core loss. If core is exist, that means the resistance is also exist inside the core, or the resistance offered by the core. એટલે આપણે શું કરીએ છીએ Vm square by R અથવા તો તમે શું કરો I square R, not an issue. અને I ને તમે કન્વર્ટ કરો V માં તો V by R. So Vm square by Rm is equal to, you can also write not Vm but Vs square by R. This Vm is the voltage exists on the, or imagine like the voltage on the Xm, the value of this future reactance. This value of voltage is similar to the value of the supply that we are assuming. And the next one is gap power. So these are the all 3 are losses. One is inside the rotor. You can see here, one is inside the rotor in terms of the rotor copper loss actually. One is inside the stator, and third one in between here, we you can see. The core loss. Some of the losses may be inside the core. Some of the losses may be from stator towards the rotor. Yes. So in short, these 3 points are belongs to the losses. Now the next point is gap power. Gap power, the power which is transferred from the stator to the rotor. The power which is transferred from stator to the rotor. So it is equal to 3 times IR square RR divided by, once it is transferred to the rotor, there may be generation of slip. Once the power is given to the rotor, that means rotor has to rotate. Rotor will try to rotate because it gets some power. That's why rotor will try to rotate. If rotor will try to rotate, there may be generation of slip. So we have to consider the value of slip as well. So it is a 3 times IR square into RR by S. He was not present in last lecture. क्या करो? We already discussed anything about the slip. Slip is as is what? In short, the difference in between synchronous speed and the actual speed. Or in another way, there is a slip. Slip matlab slip nahi hai. There is a slip of what? Of the rotor. From where? From the initial condition to the other conditions. Sometimes initial condition is the standstill condition. Motor ubi rahi. Ane ubi rahi pachi motor ચાલે. એટલે slip માં ફેરફાર, સ્પીડ માં ફેરફાર. That means there is a change in the slip. Sometimes ubi રહેલી motor ને આપણે stop કરીએ. એવું બી કરીએ. Sometimes એ જ motor ને આપણે reverse માં કરીએ. So there is a changes in the slip. Hunting of slip. Hunting એટલે શું? Hunting of slip. એવું ક્યાં સાંભળ્યું? ક્યાં સાંભળ્યું? Hunting of slip. સ્પીડ માં તો કઈ થતું હશે એને હન્ટિંગ કહેતા શું થાય? Variations. Change in the speed or variations in speed. Hunting. Hunting નું બીજું કોઈ નામ છે? Synonyms. ગુજરાતી નામ? શિકાર. Hunting એટલે શિકાર કરવો. શિકાર કરવામાં શું થાય? શિકાર કરવામાં મારા ખ્યાલથી તમે તીર મારો, તીરથી જ આપણે શિકાર કરીએ ને. બંદૂકથી પછી કરશું, પહેલા તીરથી કરીએ. તીર મારો એટલે જેની પર બી તીર વાગે એની બોડીની ચેન્જીસ કેવા થાય? ખતરનાક થઈ જાય. જસ્ટ લાઈક એ ટ્રાન્ઝિયન્ટ, જસ્ટ લાઈક એ શોક, જસ્ટ લાઈક એ સર્ચ. Similarly, if there is a such type of changes in the motor speed, suddenly there is a change in the speed, there is a suddenly increment in the speed and then suddenly decrement in the speed, just like a shock. It may be related to the hunting. Slip માં gradual change થવાને બદલે કેવો change થાય? વધારે ઓછો changes થઈ જાય. For example, 0 થી 1 થવું જોઈએ, 0 થી 0.1, 0.2, 0.3 gradual smooth change થવો જોઈએ. એવો ના થાય. 0.1 થી સીધો લઈને 0.4. There is a hunting. એવું ક્યારે થાય? બીજી મોટરનો કોઈ વાંક હોય? મોટરનો બી વાંક કદાચ હોય, પણ મોટર બગડેલી હોય તો ચાલે નહીં. મોટરને તો ચાલવું છે. એટલે whatever the input given to the machine may be having some deterioration. The supply must have been changed, or there is a input which is not properly as per the requirement of the machine. Maybe higher input or lower input, suddenly વધારે વોલ્ટેજ આવે, suddenly ઓછા વોલ્ટેજ આવે, જ્યારે મોટરનો આપણે કંઈ વાંક પડે. That means the properly converter is not working. or the output given by the converter to the machine is not properly correct. Sometimes high surge sometimes somewhere there is a short circuit, high current motor effect either voltage up, high voltage down. So any problems might be there. But because of certain changes in the parameters of voltage, power and torque and currents, there may be changes in the speed, which may be known as the hunting or the slip. In short, there is a change in the slip, a drastic change in the slip. Or for a moment, not for the entire time machine is rotating like this, yes, not like that. Sometimes it is rotating and then it will get something like that. And then it goes on the smooth speed. So the third point, fourth point is the gap power, which is power transferred from the stator towards the rotor, where it is a 3 times I square R by S. Vinod, Vajawa? Okay. Back to you after some time. Now then next point is developed power. Not PG, it is actually PG. Developed power. What we did, we give supply to the machine. There is the generated power in the stator. Then we eliminated losses of the stator. Then we observe that how much power is transferred to the rotor, which is gap power. How much power is transferred to the rotor. Once the power is transferred into the rotor, again we have to calculate some of the losses of rotor. And then after we found that there is a generation of the torque inside the rotor. That torque is responsible to produce power inside the rotor or on the shaft. That power is the developed power inside the rotor. So this developed power PD is equal to the power transferred from stator to the rotor minus the losses generated by the rotor. Minus losses generated by the rotor. Very simple. So the power transferred from stator to the rotor is equal to PG, which is gap power, which is transferred from stator to the rotor. This much power is transferred to the rotor, stator to the rotor. Then there may be some losses. We have to deduct this. These losses are what? It is a rotor components. So what you can say, PG minus PR. PG minus PR, which is equal to 3 times IR square RR by S minus 3 times IR square into RR minus 7. What it is equal to 3 times IR square RR square in bracket 1 upon S minus S, which is equal to 3 times IR square RR square into 1 minus S upon. Now what is the value of this? It is again similar to this. PG. It is again similar to this. It is equal to PG into 1 minus S. What is this? Developed. The power actually developed inside the rotor, which is responsible to the two parameters. One is the power transferred from the stator, and second, the actual slip of the machine. RR square. Oh. IR square into only RR, not RR square. So final equation for the torque, developed torque is what? PG into 1 minus S. Next one is developed torque. This one is developed power. This one is developed power. Do you remember any equation for the torque? related to power. Correct.
Sir, and this is equal to 1 of
Now here this is about torque. Here it was discussion about power. Do you remember any equation? Develop power or develop torque PD, or otherwise it was PD.
AD upon signal, PD upon signal.
Any equation related to the power, torque, or the speed? कोई एवं इक्वेशन मशीन में भण्या नहीं जेमा पावर आवे, टॉर्क आवे, स्पीड आवे? तो बोले कई इक्वेशन के पाई आई वाળું તો એમાં પાવર ક્યાં આવે છે?
એટલે તે કે પાવર
સ્પીડ ક્યાં આવે છે? પાવર આવે કદાચ પણ સ્પીડ ક્યાં આવે?
ટોર્ક ને કરંટ નું રિલેશન.
આપણે તો એવી ઇક્વેશન જોઈએ છે જ્યાં પાવર અને ટોર્ક બંને હોય. એ તો મશીનમાં ભણ્યા છે. મલ્ટીપ્લિકેશન
સર એક ઇક્વેશન આપી સર ફૂલ કે
બોલે
सर डेवलप टॉर्क का इक्वल टू PD अपॉन डेवलप पावर अपॉन डेवलप सिग्नल.
PD अपॉन
डेवलप पावर कितना हो गया है और डेवलप सिग्नल सिंक्रोनस एंगुलर
આવું ઇક્વેશન નથી ભણ્યા P બરાબર T into ઓમેગા. The power is in relation with the torque as well as the speed. તો બહુ સારું ઇક્વેશન. તમારો પાવર કેવો હોય ઓલમોસ્ટ ફિક્સ હોય. તમારે સ્પીડ વધારવી હોય તો ટોર્ક શું કરવું પડે? અથવા જો તમારે સ્પીડ ઘટાડવી હોય તો તમારે ટોર્ક અને ના કરવું હોય તો આવું થયા કરે એની જાતે. ઓછી સ્પીડ હોય ત્યારે ટોર્ક કેવું હોય? વધારે. વધારે સ્પીડ પર જાઓ એટલે ટોર્ક ઓટોમેટિક શું થાય? At that time there is no need for the extra torque. Based on this equation, P is what? P upon omega. P is what? P upon omega. So PD upon omega n. Omega n is what? For the actual speed of the rotor. Now we must, what is PD?
PD equal to 1
PD into s upon omega. Where omega m is there, it is omega s into 1 minus. This equation is familiar to you. So it is equal to Pg into 1 minus s upon omega s into 1 minus. This two can be. So what is the developed torque? Pd is equal to Pg upon omega s. See some of the equations you should remember, or the way how to carry out this equation you should remember. These are the equations useful for the electrical drive, especially AC drives or the electrical machine or induction machine. એમાં તમને કામ આવશે. આટલે સુધી ક્લિયર? Next one is the input power. Input power. It is 3 times PS IS into cos theta. 3 times supply voltage, supply current, and the cos of angle existing in between voltage and current. Another equation for this is the number 1, the losses created by the stator. Input કેટલું છે? The losses created by the stator. loss is created inside the core. Core loss, stator loss. And the third one, બાકીનો જેટલો પાવર છે એ પાવર ક્યાં જશે? રોટર માં. એટલે ગેપ પાવર, એને આપણે ગેપ પાવર કહીએ છીએ. એટલે ગેપ પાવર વત્તા the losses in the stator વત્તા the core loss. બરાબર છે? So it is equal to PC plus PG. Are you guessing? Power inside the stator loss, stator core loss, actual core loss, and then the gap power, which is power transfer from stator to the rotor. Output is what? This is what? This is the input. Input is equal to 3 times PS IS into cos of theta. PC plus PG plus PS. Similarly, output power is what? Final output power, what we discussed, that developed power, right? Power developed minus no load. Actually જેટલો પાવર આપણી પાસે શાફ્ટ ઉપર કે રોટર ઉપર આવી ગયો છે, જે પાવર ડેવલપ થઈ ગયો છે, એમાંથી બી આપણે થોડો પાવર ડિડક્ટ કરવો પડશે. કયો કે નો લોડ લોસીસ. નો લોડ લોસીસ આમાં તમે બધું કન્સિડર કરી શકો. ફ્રિક્શન લોસીસ થી માંડી, વિન્ડેજ લોસીસ થી માંડીને ઓલ ધી લોસીસ યુ કેન કન્સિડર. નો લોડ લોસીસ. So the efficiency is what? Efficiency is what? It is equal to KD minus upon AC DRU PSU the PG. Generally, this developed power is greater than the no load losses. So PD is greater than no load. Similarly, this PG is also greater than the rest of the two. So PG is greater than PC plus PSU. So what would be the next approximate equation? That is PD upon what is the value of PG in terms of PG? Sorry, PD in terms of PG. It is PG into 1 minus S upon PG. You can simply say that PG can be cancelled. It is 1 minus S, which is equal to so the efficiency is also related with the slip. Slip S બરાબર તમે 1 મૂકો તો efficiency શું છે? 0. मतलब 1 છે ત્યારે મોટર શું છે? 1. તો બી છે, બંધ છે, આરામ કરો ત્યારે ફરતી નથી, मतलब efficiency કોઈ આવડે અને S બરાબર 0 મૂકો मतलब કે સિંક્રોનસ સ્પીડ પર છે, તમારી મશીન ચાલે છે ત્યારે we are assuming that the efficiency is very large. It is up to the 100%. આટલે સુધી ક્લિયર થયું? બધા ઇક્વેશન્સ સ્ટાર્ટિંગ ફોર ધી કોર લોસ, કોપર લોસ, સ્ટેટર લોસ, બરાબર, ગેપ પાવર, ડેવલપ પાવર, then input power, output power, then the efficiency. 5 to 10 equations. These are the equations we should remember. Now basic equations આપણા માટે કામનું શું છે આગળ જતા? Important equation is stator. You can assume stator, there is a rotor, inside the rotor there is a rotor current, and because of the presence of the rotor current there is a rotor torque. Because of the rotor torque there is a rotation of the rotor. એટલે આપણા માટે આગળ જતા શું થશે કે rotor is responsible for the rotation, there is a torque, current અને બધું આવશે. આગળ જતા આ બધું આપણા માટે એટલે rotor current is also important. એટલે હવે આપણે શું કરવાનું છે? rotor current we have to find out. પછી stator current also we can find out. આવું બધું કરવું પડશે. અત્યાર સુધી આપણે IR લખ્યું, IS લખ્યું, but we have to see in the detail of the IR इबे IR માં શું છે તો what is IR માટે તમારે શું કરવું પડશે આ કરંટ શોધવો પડશે એ કરંટ શોધવા માટે આ કરંટ શોધવો પડશે એના માટે તમારે ઓવરઓલ ઇમ્પિડન્સ શોધવું પડશે supply voltage divided by the overall impedance or the impedance offered by the rotor. First of all, let us find out the input impedance ZR. Input impedance is a one branch. See, this is one branch and this is another branch. Let us say it is a Z1, it is a Z2. What is the impedance? Zi is equal to Z1 parallel Z2. Z1 parallel Z2. Z1 you know that it is JXM. Z2 is what? RS plus JXS plus RR by S plus JXM. આટલું Z1 Z2 છે બંનેનું પેરેલલ કરો find out the final equation for this. Z1 is what? JXM. Z2 is what? This RS plus RR by S plus J into XS plus XR. Very simple नहीं આવતું કેમ ના આવે JXM into in bracket RS plus RR by S plus J of XS plus XR बराबर अपन ये मल्टीप्लाई नीचे प्लस JXM plus RS RR by S JXS JXR JXM multiply by this JXM in bracket RS plus RR by S J into J square is minus 1 minus XM in bracket XS plus XR upon this में J equal to ले लो real RS plus RR by S plus J comma XS plus XR plus X निकली जाए ने क्या निकले हाँ तो ये क्या निकले से मल्टीप्लाई विद RS plus RR by S એમાં તો કોઈ J છે જ નહીં એક J से થવાનો નથી એક માઈનસ 1 થવાનો નથી J છે તો J જ રહેશે ને હવે આન્સર લઈ લો તો J સ્ક્વેર થાય ને This is what? JD. તમે એવું કોઈ ટાઈમ સેટ કરો જેથી લેક્ચરમાં તકલીફ નહીં પડે. યાદ કરો. What is PD? What is PG? K2. What is IR? IR is what? VS upon RS plus RR by S square XS plus XR. There is a root, but here it is a square. Root જતું રહેશે. અહીંયા VS ના બદલે square. VS square upon this. Divide by जो IS का मार्किंग છે RR by S into omega S. S omega. What is developed torque? That is 3 times RR into VS square upon S omega S in bracket this bracket 1. This is what? The actual torque developed inside the rotor. Is it clear? આજે બીજા કોઈ લેક્ચર છે તમારો? લાઈવ નથી.